Hello, my dear students. Students, now we are going to discuss the most important question from the atomic structure, that is, what are quantum numbers, how they are arrived, explain their significance. Okay, what are quantum numbers? How can we define the quantum numbers? These are the set of numbers which can give the complete description of electron present in an atom. That means, for example, an electron present in an atom, that electron present in which orbit, which subshell, which orbital, what is the spin of electron, what is the orientation of orbitals, all these things can be explained with the help of quantum numbers. Okay, students, what are quantum numbers? These are the set of numbers which can give the complete description of electron present in an atom. The set of numbers the set of numbers which can give the complete description of electron present in an atom are called quantum numbers. How they are arrived means, these are derived from the Schrodinger wave equation. These are derived from Schrodinger wave equation. These are derived from Schrodinger wave equation. Schrodinger wave equation. These are derived from the Schrodinger wave equation. To know the state of electron or the position of electron in an atom, we required four quantum numbers, or we have four quantum numbers. To know the position of electron, or a state of electron, to know the position of an electron in an atom, we have four quantum numbers. We have four quantum numbers. We have four quantum numbers. See, first one is principal quantum number. The first one is principal quantum number. Principal quantum number. Now let us discuss the significance of one by one. First of all, what is principal quantum number? The principal quantum number introduced by or discovered by, proposed by Niels Bohr. It was proposed by Niels Bohr. It was proposed by Niels Bohr. It was proposed by Niels Bohr. It represent with the letter. It represent with the letter N. Proposed by Niels Bohr, represent with the letter N. The values of N are, the values of N are 1, 2, 3, 4 and so on, are K, L, M, N and so on. Okay, next. The main important point is significance. significance. Mainly it explain or it describe the size and energy of the orbit. Size and energy of the orbit. It explain or it describe the size and energy of the orbit. Size and energy of the orbit. Okay. That means as n value increases, size and energy of the orbit also increases. As n value increases, size and energy of the orbit also increases. That means what? See, this is the orbit, nucleus, and around the nucleus the path of electron, which we can call as orbit. Okay. See, this is the first orbit, second orbit, third orbit, fourth orbit. Are n values. N value 1 first orbit, n value 2 second orbit, n value 3 third orbit, n value 4 fourth orbit. As n value increases, see first orbit size, observe the first orbit size. Second value, n value 2 means second orbit, third orbit. Compare the n value 1 first orbit and the n value 4 fourth orbit. The size of the first orbit and fourth orbit is large size. That means as n value increases, size of the orbit also increases and energy of the orbit also increases. Size and energy of the orbit increases. This is fourth orbit, valence shell. The valence shell is called last shell or fourth shell. So as n value increases, size and energy of the orbit also increases. In your examination, no need to draw the diagram. Just for understanding purpose, we can draw the diagram. As n value increases, size and energy of the orbit also increases. Is it clear? So, principal quantum number. Simply just you have to remember proposed by Niels Bohr, represent with the letter n. The values of n starts with are 1, 2, 3, 4 or k element. The main important point is significance. The significance is it explain or describe the size and energy of the orbit. Size and energy of the orbit. Is it clear? Next. Second one is angular momentum quantum number. Second one is angular momentum quantum number. See, angular momentum quantum number. Angular momentum quantum number. It can be represented with the letter n. Angular momentum quantum number, otherwise it is also known as azimuthal quantum number. Azimuthal quantum number or angular momentum quantum number or azimuthal quantum number. Azimuthal quantum number. It was proposed by Sommerfeld. It was proposed by Sommerfeld. It was proposed by Sommerfeld. Okay. It represent with the letter. It represent with the letter. Small l. The values of L. The values of L are 0, 1, 2, 3 and so on, the maximum value is n minus 1. N minus 1. The minimum value or least value is 0 or starts with 0 and the maximum value is n minus 1. The next one is significance. Significance. It describes the subshell present in a main shell and the shape of the orbital. It describes the subshells or sublevels. Subshells present in a main shell and shape of orbitals. And shape of orbitals. Subshells present in a main shell and shape of orbitals. Let us see here subshell L value, orbital, shape. Okay. S subshell L value is 0, orbital is S orbital, shape is spherical. For P subshell L value is 1, orbital is P orbital, shape is dumbbell shape. Dumbbell shape. For D subshell L value is 2, orbital is D orbital, shape is double dumbbell. Double dumbbell, right? For D subshell L value 2 and the orbital is D orbital, the shape is double dumbbell. Next F subshell L value is 3, F orbital 4-fold dumbbell. 4-fold dumbbell. So these are the orbits. In that orbit there are subshells are present. In that subshells orbitals are present. In that subshells orbitals are present. So S subshell L value 0, orbital S orbital, shape is spherical shape. P subshell L value 1, orbital is P orbital, shape is dumbbell. For D subshell L value 2, D orbital double dumbbell shape. F subshell L value 3, F orbital. For F orbital it is a complex structure. We can represent with the 4-fold dumbbell. Here dumbbell, double dumbbell and then 4-fold dumbbell, right? So this is the significance of angular momentum quantum number or azimuthal quantum number. Okay students. Next. See, next one is magnetic quantum number. The next one is magnetic quantum number. Magnetic quantum number. Magnetic quantum number. It was proposed by Lande. Name of the scientist Lande. It represent with letter. It represent with letter. M. M values. The values of M. The values of M are minus L to plus L including 0. including 0. That means m values are dependent on angular momentum quantum number. M values are dependent on L values. The possible m values are starts with minus L to plus L including 0. Right? See the significance. What is the significance of a magnetic quantum number? Let us see. Magnetic quantum number mainly explain the orientation of the orbitals. Orientation of orbitals. Right? It explains or it describes the orientation of orbitals. Orientation means simply the orbitals are rotating in three-dimensional along x direction, along y direction and along z direction. So that is called orientation. The orbitals which are rotating in 3D manner, three-dimensionally, that is called orientation of orbital. It explains or it describes the orientation of orbitals. See, for example, if L value 0, if L equal to 0, possible m values are possible m values. When L value 0, here minus L means minus 0, plus L means 0, and including 0 means the possible m value is only the possible m value is only 1, that is 0. Okay. If L value 1, possible m values are possible m values minus 1, 0, plus 1. That means the possible m values are minus L. That means L value is 1. So minus 1 plus L means plus 1. Including what? 0. That means minus 1, 0, plus 1. Total 3 values. 3 values. How many L values? How many possible m values? 3 values. What are they? Minus 1, 0, plus 1. If L value 2, minus 2, minus 1, 0, plus 1, plus 2. Total possible m values are 5. What are the values? Minus 2, minus 1, 0, plus 1, plus 2. Okay. Magnetic quantum number proposed by Landé, represented with the letter M. M value starts with minus L to plus L including 0. The main important point is significance. It mainly explains the orientation of orbital. Orientation means rotating the orbitals in three-dimensional manner. If L value 0, the possible m value also 0. L value 1, the possible m values are 3. What are the 3 values? Minus 1, 0, plus 1. Okay. The next one is spin quantum number. Spin quantum number. Spin quantum number. Spin quantum number. Yes. It is introduced by Uhlenbeck and Goudsmit, or it was proposed by Uhlenbeck and Goudsmit. Right? It was proposed by Uhlenbeck and Goudsmit. Here U, capital U. It represent with the letter. Yes. The significance. It mainly explain the orientation. It mainly explain the direction of the spin of electron. Direction of the spin of electron. It explains the direction of spin of electron. That means in which direction, whether it is clockwise direction or anti-clockwise direction. Clockwise or spin of electron. Mainly explain the spin of electron, whether in clockwise or anti-clockwise. Generally, the spin of electron in two directions. One is clockwise and another one is anti-clockwise. It explains the direction of the spin of electron. There are two directions. If electron spin in clockwise, we can represent as r plus half. If electron spin in anti-clockwise, we can represent as downward arrow or minus half. Simply clockwise plus half. This is clockwise. Minus half or downward arrow anti-clockwise. Okay. Spin quantum number represented with the letter S, introduced by or proposed by Uhlenbeck and Goudsmit. The significance of the spin quantum number is explain the spin of electron. Generally, the spin of electron in two directions. One is clockwise, another one is anti-clockwise. If the clockwise, we can represent upward arrow or plus half, anti-clockwise downward arrow or minus half. Okay, students. So these are the four quantum numbers. Very, very important one in your annual examination. Explain the significance of the quantum numbers. What are quantum numbers? Explain their significance. Okay, right? Next. My dear students, this is the long answer question. In simple manner, in simple method, how can you revise this long answer, right? Simply just you have to write the quantum numbers. Okay, quantum number principal, number one principal quantum number, second one is angular momentum quantum number, third one is magnetic, fourth one is spin quantum number. Next one, introduced by or proposed by, introduced or proposed by principal quantum number Niels Bohr, angular momentum quantum number Sommerfeld, magnetic quantum number Lande, spin quantum number proposed by Uhlenbeck and Goudsmit. Next, representation or indicate, represent with principal quantum number N, angular momentum quantum number L, magnetic quantum number M, and spin quantum number S. Okay, and the values N values 1, 2, 3 are K, L, M, and so on. L values 0, 1, 2, 3, and so on. M values minus L, 2 plus L, including 0. Here S value, spin quantum number, we can represent the plus half, plus or minus half, or plus half and minus half, clockwise and anti-clockwise. And significance. Principal quantum number mainly explain the size and energy. energy. Okay. And Anglo-Mondo quantum number, shape of orbitals, shape of orbitals and subshells. Explain the subshells present in main shell. And third one, magnetic quantum number, explain the orientation. Explain the orientation of orbitals. Orientation of orbitals. And the spin of electron. Fourth one is spin of electron. Right? In this method, you can easily revise the long answer question. So make the table, principal quantum number introduced by, represent with values and significance. Before going to exam or within 2 or 3 days before, just you have to revise the table and you can easily explain the one by one. Okay students, so it is the quantum number and how they are arrived and the significance of the quantum numbers. Okay students, thank you very much.